Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So one of the questions that people ask me all the time is, hey Rich, what are you going to do on the channel next week? And they're always surprised to hear that I usually have no idea what I'm going to do on the channel next week. I mean, it's not always true. I mean, sometimes, especially if it's going to be a video that is like kind of a series, like 2 or 3 videos long, I usually have somewhat of a rough plan, but generally speaking, I really don't know what I'm going to be working on next week. Just something always comes up, and it's been that way long before I started the channel. It's actually the reason that I started the channel. It just seemed like I was always working on something, fixing something, making something, adding a feature onto something with 3D printing, and I thought, hey, may as well turn the camera on. And this week is no different. I finished cutting the grass. I went to get my trusty string trimmer to chase down all the weeds and grass at the edges that I can't reach with the mower, including all the way down at the very corner of our property where I have this like big concrete block and a culvert pipe that runs underneath the road. And wouldn't you know it, every single time when I'm at that furthest point on my property, that's when I run out of trimmer line on the string trimmer. And if you're not familiar with a string trimmer, here, let me move this over. This just has a head on it, and this head has about 18 feet of line that wraps up in it, and you actually knock this against the ground while it's spinning and more line comes out, and that line is very similar to 3D printing filament. It's made out of nylon, and this spins around and it cuts the weeds. It does a really good job getting up in places where you just can't get in there with a mower or anything else. And of course the string trimmer isn't very useful without trimmer line on it, and I've actually tried to head this off before by pre-cutting a piece and putting it in my pocket. And sure enough, whenever I remember to do that, that's not when I run out of trimmer line, and then I forget to put it in my pocket next week. So it'd be pretty cool if we could come up with a way to actually store some extra trimmer line somewhere here on the trimmer. I'd also like to see if we can eliminate the need for having the tape measure to measure out a new piece of line. This Echo string trimmer claims to hold 20 feet of line, but I think that's a bit optimistic. Anytime I've measured out 20 feet of line, it always seems to kind of get caught up in the head. I usually measure out 18 feet of line using the tape measure, and that winds up in there no problem. So yeah, I wonder if we can find a way to either maybe with like the number of wraps or something that would get us a consistent, about 18 feet of line without needing this guy. All right, I pulled you guys out of the tripod because it's awkward trying to get this entire string trimmer into the shot. And I want to kind of eyeball where it's going to make sense to try and mount some extra line on here. This is a gas engine. It's a 2-stroke gas engine. It does get pretty hot, but I mean, all the shroud on here is, some sort of plastic material now, but I don't think that's the best spot to try and do it anyway. Then we have the throttle and safety grip and the off switch. There is a handle here. We could potentially mount it maybe on the underside of the handle, maybe even reuse those same fasteners, or we could put it on the shaft. I don't want to go too low on the shaft because you can see from this end here just the buildup of grass and weeds would get pretty messy. But once we reach kind of like up maybe here, there's not too much junk on there. I do sometimes grab the trimmer here. That's because that's the center of gravity. So just picking it up and carrying it with one hand, that's where it's comfortable to carry. So yeah, I'm thinking maybe somewhere in this area. Let me get a measurement on that shaft. All right, looks like that is just about dead on 25 millimeters. As I rotate it around a little bit, the measurement changes a bit, but I think that's just, grass and stuff on here. So I'm gonna go with 25 millimeters. And I think I'm just gonna go up to CAD and just kind of start sketching some stuff and think this through. So I'm gonna do that. I'll bring you guys back. All right, and here is the initial design that I came up with. And this is really just to get kind of an idea if this is going to be enough room to wrap that cord around or if we're going to need to make this larger. The only real 2 elements in here are these 2 holes. I put that in thinking that we're going to need something to insert the line to sort of hold it in place as we start to try and wrap it around here. And I left this open here figuring, I can't think of how we're going to do this to avoid supports. I mean, I guess we could always make it 2 parts that sort of go together or glue together. I really don't want to do that. So I figured, we can cut these parts off here and minimize the amount of supported area that we need on this. I also drew the pole in here too, the shaft of the string trimmer, just to get kind of an idea of scale. It really helps, like if you're going to have something that ultimately gets mounted to something else, as a first step, try and draw the rough shape of that thing, just, to make sure you're not completely off from a scale perspective. So, all right, let's print this out and see if it works. All right, our first test print is complete and looks okay. This is some really old PLA that I'm just trying to use up for prototyping. to get rid of it. I ought to just throw it out. It prints really bad, but I have a hard time throwing stuff out if I feel like I can get some value out of it. So yeah, it is what it is. I've gone ahead and cut 18 feet of line here. So let's see if it fits. Let's see, first of all, if our little hole here to hold this works. Put this, oh, it's a little tight. It does go. I might enlarge that a bit for V2. All right, well, that'll fit on there really nice. Actually, we have way more room than we need. We could probably fit another 18 feet of line on here. So I think we can reduce the size of our spool ears, I guess you'd call those. I think I'm gonna keep the distance between the centers here the same. We could size that down a little bit, but it's easy to wrap like this. Turning this stuff any tighter, like a tighter radius, it gets a little trickier, I think, to keep it on here. Like even this, I had to wrap the first couple wraps pretty tight just till it stayed in place nicely. I'm realizing that I've got nothing to do with this end now. I mean, I guess we could tuck it in here. It would probably stay. But what if we gave ourselves some more holes on here? That hole to hold the line to start the wrapping, that worked really well. So what if we had, 2 or 3 more on each side to give ourselves like a couple different options for what we do with our loose end? And let's see how this fits on here. Yeah, I don't think that looks out of place. Although, how are we going to wrap that with the handle there? If I unwrap this a bit. Yeah, I mean, I could do it, but the handle is kind of in the way. I guess we could flip this over. Oh yeah, that'd be a lot easier. Now the handle's not in the way, so that sort of natural motion of wrapping your hand around is going to be a lot easier. Yeah, I think let's plan on putting this at the bottom, which means we're going to need some type of clamps or something on the top, which that's kind of a weird shape to have. Like if we did like a minimalistic clamp, following that curve is just going to be kind of difficult. Yeah, I really don't want to square this off to facilitate us clamping this in place. I think we can figure out a way to do it. Maybe if we just had, what if we just took this same oval shape and sort of had like a cover that went on top of here? Then we could have our bolt holes like 2 here and 2 here, and that should stay in place really nicely. I guess it could look a little bulky, but it's not like it's going to be in the way because this is the forward grip with your hand on it like this. Yeah, let me go back up to CAD. I think well, you know what? We're also going to shrink this overall. This oval is the whole oval shape here is going to be a little bit smaller. So imagine that maybe 5 millimeters smaller. And then we do like a cap that goes over this to secure it in place. We could do, the bolts would go in, or the machine screws really would go in from here. I guess to fasten them, we'd probably need some clearance holes to get to the heads of the fasteners. Now, let me think that through. Let me go back up to CAD. I'll bring you guys back. All right, and here is what I hope is the final design on this. And the bottom part is not significantly changed. I did thicken up the top plate here just to allow for a counterbore on some M4 machine screws to sink in there a bit so they don't interfere with the area that we're going to wrap the cord. Added some bevels here just to strengthen this up. I reduced the overall side of these ears, and I just kind of rounded things off nicely. I did add 4 more holes up here at the top, so wherever we kind of end with our line with that loose end, so that we've got a couple different places to put it through. And I added a second hole at the bottom so we can either start wrapping from here or start wrapping from here. I did end up putting 4 holes in for access to those machine screws. I can't think of another way to get in there. I mean, I guess we could use like a really short Allen key, but then we got to find a really short Allen key. So I figured it's just easy to put the 4 holes in here and just use a regular Allen key and reach through to get to those heads. I did end up doing, pretty much a full cap here on the top. I'm a little worried this is going to look bulky, but I couldn't think of a better way to design this top that it was going to be, strong enough that it's not going to distort and ultimately slip on here. I mean, we could probably skip this altogether, just add 4 holes down here and use zip ties, but zip ties tend to loosen up over time. And I'm worried, especially with the vibration on this, that eventually this thing's gonna work its way down the shaft. I think if we squeeze it nice and tight with 4 machine screws, this thing should stay fixed in place. So I think it's worth it to do the cap on the top. And I did a little inset here because I'm probably gonna do a second color there. You guys will see what I'm up to there later on in the video. But for now, let's get this printed, see if it fits. All right, our parts are complete and these came out really nice. This is also PLA that I'm just trying to use up and get rid of, but much nicer PLA. This is Hatchbox PLA, and I used to buy exclusively Hatchbox PLA, and it went up to like $28, $30 a roll, and I just didn't want to spend that much. So I started buying the Sunloose stuff at I think 13 to 14 bucks a roll, and it was a slight step down from the Hatchbox stuff, but not enough that I wanted to pay twice as much for the Hatchbox. And then eventually I switched to the bamboo stuff because it's pretty much the same price as the Sunloose if you're buying it in bulk. And it's as nice as the Hatchbox and has the RFID tags in it. I hope they never raise the price. I know that's what everyone's afraid of. And all the naysayers that don't like bamboo saying, oh yeah, they're going to get you hooked and then they're going to raise the price. I don't know, maybe. But until they do, I like the bamboo stuff. It's as nice as the Hatchbox. All right, let's see how this fits. So our bolt holes are here. So this is going to go on here. That'll go on there. That's not bad. I mean, I guess it looks a little bulky, but it's not in the way. And we could probably put something on there to sort of set that off a little bit better. All right, I sized these for M4. I think M4 by 12 is probably going to be the right size. And this is actually the same set that I used in last week's video. I'll link this down in the description again. I don't know how well the camera's picking that up, but we've got a really nice set of threads in there. All right, before we tighten these down, we are actually upside down. We want this rotated like that. All right, that's pretty tight, but I think we could probably tighten that up on our final version. And all we should have to do that is actually just lower this top face on our bottom part. If we bring that down, we will tighten up the sort of the clamping action of this top plate coming down on that. So, all right, let's try actually wrapping up our line on here. Oh, and I should probably count, because my plan is to count the number of wraps and then just make a note on this somewhere for how many times you wrap around to get 18 feet of filament. 1, 2, 3, 4, 5, 6, 20. All right, that ended up being exactly 20 wraps, which is kind of funny. I guess I could probably remember that, but we'll still find a way to mark that on here. And I think I'm actually going to unwrap half a wrap, go through these two. And then I got to, it's actually a little bit loose. I probably should have just kept it there. Oh yeah. Yeah, it still goes through both of those holes, and I can't imagine that's going to vibrate loose. All right, at this point, I think I'm pretty happy with the design. I'm happy with the function of it. I'm happy with the appearance of it. I am going to adjust that face a little bit just to tighten up the clamping action on here. But I don't want to go with PLA for our final version. This is going to sit out in the sun, and it's going to be in the sun while I'm using it too. So it's possible this gets hot enough that it could warp. I want to do it in PETG, and I've actually thought ahead on this. I do have a roll of orange PETG and a roll of dark gray PETG that I think will match this machine nicely, since these Echo machines are orange. So I'm going to go get started on that. But while we're doing that, I'm going to show you guys something I've been messing with. So a couple of months ago here on the channel, we did a bunch of work to try and silence the radon mitigation system installed here at my house. It was super noisy. You could hear it even over regular volume conversation sitting on our back patio, and I really wanted to quiet it down. I thought that most of the noise was coming from the air exiting the pipe at the top, and I messed around with a bunch of different like gyroid infill, open inside, like no walls on the interior, like different designs to try and silence it. It helped a bit, but many folks in the comments suggested replacing the fan itself. It sounded like the bearings were bad on the fan. And replaced the fan in a follow-up video, and sure enough, it was a lot quieter. But at the time, I set that fan to basically move the same amount of airflow as the original fan. And I really wondered, do I need to do that? Can I run it even slower without getting into, dangerous levels of radon in the house? And I showed this guy. This is what I used to measure the radon levels. And these work really well, but it's a point in time. So I went up to the website of the company that makes these. I've got 2 of these. One of them I've had for probably about 7 years, and then 2 years later I bought another one for out here in the garage. And that's this one. I've had this one for probably 5 years, and both of them still work fine, but they're point in time captures. I mean, it gives you a 1 day, I think a 7-day and a 30-day average, but you can't really see trends. And that's what I wanted to do. I wanted to be able to see what the trend of radon looked like over time if I made adjustments to the fan speed. So I went up to their website and they sell a much more advanced version of this. And that is this guy here. And this is the View Plus from AirThings. And full disclosure, when I saw this on their website and realized how perfect it was going to be for what we're trying to do, because this records the data and trends it over time in their app, I did reach out to them and asked if they'd be interested in sending one out to the channel for us to play with. And they said, yeah, sure. What's your address? We'll send one out. So I actually thought I'd be showing this to you guys much earlier. But when I started to record the radon data, I realized just how much it actually changes over time. I realized I needed a much longer time to get kind of a baseline because it goes all up and down. I'll show you. In addition to having an app for this that is free, what really attracted me to these guys was they have an API. And I have a bunch of data that I already collect, environmental data here at the house. Like I have the temperature and humidity logged over, I think at least a full year, as well as a bunch of other data that I collect. And I pull that into Cacti, and I can pull all that data in from their API, which is also free. You just register as a developer, get an API key, and you can pull down all the data. And this View Plus gives us a bunch of other data as well. This is actually the model up from the one that I was originally looking at on their site that they sent. This one shows radon. I have it set to display here humidity and then also particles in 2 different sizes in the space as well. Now I pulled this out to my garage shop to show you guys, but this has been living down on the bench right in the room where I have all my 3D printers set up. And I thought it'd be really interesting to see if you could see the particle or VOC levels, go up and down as I had a bunch of printers running. And yeah, that didn't go quite as I expected. I'll wait till I show you the data. So here's what the data looks like on the AirThings website. And they have an app for your phone as well, but you can see a lot more on the website. I just prefer to look at it here, but they do have a phone app. And all the different things that the View Plus measures are radon, PM 2.5 particles, CO2, humidity, temp, VOX, pressure, and PM1 particles. And it's these PM particles and the VOX that I thought was really interesting. I kind of expected that we'd see some peaks on here when I had a bunch of 3D printers running. And you notice VOX never really went up into unsafe levels with the exception of this one instance here, but I see it lines up with a peak on the particles. And this is where it gets interesting. You're probably thinking that, oh yeah, look at these peaks here. Yeah, that does not coincide with when I was printing a bunch of stuff. That coincides every single time with when we were cooking. And this wasn't even on the same floor as our kitchen. So yeah, if you're worried about particles when you're 3D printing, I wouldn't be. Now, that said, I only print with, I primarily print with PLA, PETG, and TPU. If I was printing with much more volatile materials, that might not be the case. But I can tell you for those 3 materials, it never even showed up as a blip on here. All of these peaks are when we were cooking in the kitchen, like stir frying something on the stove or something like that. And that's with the vent fan running too. So yeah, kind of an eye opener, how bad your air actually gets in the house when you're cooking. But let's focus on the radon. So if we take a look at radon, this is on the month view. Let's change this to year. Now, we don't have a full year's worth of data, but look at this. I made no change to the fan settings during this period of time. Now, I want to point out, this is all under a value of 1. I think the action level for radon is 4 or higher, and they recommend between 2 and 4 if it consistently stays there. You should take action, so I'm well within safe levels here. But look at that variation. With nothing changed on the actual mitigation system. That's just differences in seasonality and weather. You can see right now we're at about 0.7. All right, let's go out and adjust the actual fan speed on that Radon fan. I think we have about a month and a half worth of data here, which is pretty good. So we'll adjust it. Probably have to wait a whole another month and a half till we really see what kind of impact we made, just given the swing that we have here just from, weather and seasonality. It really is amazing just how much quieter this system is after replacing this fan unit. Now, I don't know for sure if it was all the fan unit. We also replaced the thin wall sewer pipe that was here with solid core 4-inch PVC. And we also designed and printed that TPU grommet up there where it goes to the soffit, so any resonance that's in the pipe can't get carried into the soffit. Kind of turn the soffit into a speaker. So, and that was all suggestions from the comments, so I really appreciate that, guys. I mean, this is so much quieter now. The noise of this does not stand out in our backyard anymore, but if I listen for it, I can still hear it. And that's why I do want to open this back up, and let's adjust the fan speed down a little bit. And then we'll come back to this in maybe a month, 2 months, and just see how it's affected the actual radon level. All right, it looks like this is set at about 6 right now. Let's go down 1. Let's go down to 5. Oh, wow, that actually makes a significant difference. I can hardly hear it at 5. So let's try that. I would be concerned if I couldn't actually monitor the radon levels in real time. But since I can, I'm going to set it at 5, and I'm just going to keep an eye on it. Let's see what happens. All right, our parts are complete, but it wasn't without some challenges. So this is the first part that I tried to print, and it completed, but you can see the supports there where this actually got knocked out of the way. And even in the areas where it completed, they're not very clean. That's pretty ugly under there. And I printed this with the same, I printed this one with the same support settings that I did the PLA one. And the PLA one, the supports came off really clean. And it's nice and square all the way around. Yeah, not so with PETG. So I adjusted the support settings and switched colors as well. This also gave me the opportunity to kind of just play around with whether I wanted the top and the bottom the same color. So this one I printed with the support settings with an extra interface layer at the top. And you can see it completed, but it's not super clean. And you can also see like there, if we look at it from kind of end on, like this should be a nice solid front face. And up here, you can see it kind of lifted. And it's not super clean. I guess it didn't really lift. It just didn't stick there. We could use this. That's not preventing us from using it. But I went and I tweaked. I added one more interface layer, and I reduced the distance of the top interface layer to the print by, I think, half or 0.05 millimeter. I think I went from 0.2 to 0.15, if I recall, and came up a lot cleaner. So yeah, if your supports aren't working out, tweak the settings. In this case, I added more interface layers and just reduced the interface distance in the Z at the top. And that came up so much cleaner. Yeah, it would be even cleaner if we did this with TPU supports. We'd have a layer that probably looked just as clean as this bottom one, but yeah, it's probably not really necessary for this. We don't even see that once this is installed on here. The top part, I printed in 2 different colors. It's actually the same dark gray PETG as the bottom part. So this is going to look like, well, it's going to look like that, which I think looks pretty good on here. The orange is actually a really good match for this machine. And I can feel this rocking on here just a little bit since we lowered this face to tighten up that squeeze on the bar. So hopefully we didn't go too far. I think I only adjusted it by 0.2 millimeters, but maybe that was too much. Guess we'll find out. I want to show you guys another trick. Or really not a trick, something I learned that also was not what I expected. So of the parts that I have here, I think it's probably most visible on maybe this one. You guys look at the bottom of this. Do you see what looks like almost staining on the bottom of that part? This happens to me fairly often on the textured PEI sheet, and it's annoying because if you actually want that to be like your nice finished surface, it doesn't look very good. And I always assumed that that was residue that was getting picked up by whatever I printed. And maybe it is, but I don't think it is. Let me show you something that I discovered kind of by accident. So I have shown this on the channel before. This is just a hot air rework station that's actually intended for electronics work that does a really great job for cleaning up 3D prints. So this guy is going to heat up to, I think, around 600 degrees Fahrenheit. And when I'll typically use this is like if I deburr parts or if I have to trim parts, oftentimes it discolors the part, like especially if it's a black part, it'll turn kind of whitish in those areas. And going over it with a heat gun, particularly one that you can closely control the temperature of so you don't overheat the part, cleans it up really nice. And I'll put a link to this guy down in the description here if you're new to the channel. But take a look at this. So you see that surface on there that looks kind of like stained? I think what's actually happening is I think that is stress marks on the plastic when it sticks to the sheet really well. Because this is I'm not going to say coming off because that's not really what's happening, but this is remelting the same as when I have areas on the part that I have trimmed that get discolored with the heat gun just as nicely. Like I didn't do the best job going over this because you guys are kind of in the way of me seeing, but even just with, briefly going over that, you can see how we've restored the, the original, call it luster of that surface, and it matches all the other areas. Yeah, there's still some here. Get you guys even closer. You can see it almost looks like I'm just like airbrushing a color onto there. There's some over here still too. Yeah, hopefully the camera is picking that up. I discovered this by accident because one of these other parts, I had some marks on the sides from the supports. Yeah, there's actually one right there. And I went to clean up that little mark and I noticed that the markings on the bottom of the print disappeared as well. So I think that's what's going on. I don't think it's actual residue that's getting stuck to the bottom of the part. I think the surface of the plastic is getting stressed when you're removing it from the sheet when it sticks really well. Either way, whether it's residue or whether it's stress on the plastic, the heat gun cleans it up really nice. All right, I just cleaned this one up off camera. It's a little bit tricky to see with the camera right in front of where I'm trying to work, but you can see how nice that surface is now. And I didn't wipe that down with anything. That is just the heat gun. All right, well, if you guessed we were going over to the fiber laser next, give yourself a pat on the back. So I was tapping these holes off camera on this part and ran into a bit of an issue. The PETG does not tap as nice as PLA. The PETG, even going really slow, just kind of seemed to gum up in there, and I might have actually messed up the threads in this hole. And before I went and did the next one, I thought, you know what, I wonder what would happen if I sprayed some Windex in there as kind of like a lubricant. When you thread in metal, you usually use like an oil. And here, I'll do the last one on camera. This worked incredibly well. So that ended up tapping just as cleanly as PLA now. So if you run into that issue, if you're tapping threads in PETG, spray some Windex in. I just blew the holes out with the air compressor as I don't want to trap the Windex down in there. I guess the only downside is you probably do want to make sure you dry your tap off or that could potentially rust. But that works surprisingly well. All right, I went and I just hit the tap with some WD-40 quick before I put it away so it doesn't rust. And for those of you that don't know, that's actually what the WD in WD-40 stands for. It's water displacement. And I think it took them 40 tries to get the formulation right. Well, guys, I like to think that we have successfully saved humanity from another horrible first world problem. And I think this thing looks great. If I saw this on somebody's string trimmer, I would genuinely believe it's a real product that they bought at the store. And if you want to make one of these for yourself, the STLs for this and everything that I design here on the channel, I give away completely for free. Those files are all up on my site, fpfdesigns.com. I will link that down in the description of this video. So do me a favor, if you enjoyed this video, if you got anything out of this at all, take a second, hit the like button. Really helps out the channel. And let me know down in the comments if there's anything you would have done differently with this design. Is there any different design elements that you would have considered? Any different materials? Anything like that? Let me know down there. And if this is by chance your first time here on the channel, this is all we do. It's all functional prints. I don't do any of that multicolored, garbage of the week. I'm not saying there's anything wrong with that. It's just not what we focus on this channel. I focus on primarily the engineering and more functional side of 3D printing. So if you're into that, check out some of the other videos on the channel. I think I've got over 200 functional printing videos out there at this point. And if you like what you see, hit the subscribe button. And guys, if you do, I'll see you next Friday.